Okay, so here what we are going to look at is we're going to look at the first of two special cases that might occur when we're looking to do our Gaussian elimination. So the first one we're looking at here is inconsistency. So what we're going to do is we are going to consider the set of equations x plus 2y plus 2z equals 11, 2x minus y plus z equals 8, 3x plus y plus 3z equals 18. Okay, and even just from the way I've written some of these, we can start to see why I put a line through my z, because my 2 all of a sudden looks very similar to that z there. The only thing that they've got different between them is the line. Okay, so for all the kids that always ask, there is your answer. First thing we're going to do, as always, I'm just going to put it into my matrix. Okay, so augmented matrix form, I've got my coefficients 1, 2, 2, 11, 2, minus 1, 1, 8, 3, 1, 3, 18. Dotted line, brackets, good to go. So what we're going to do is we're going to go about transforming this into upper triangular form. And this is going to be the start of our few reasons that our upper triangular form is more useful to us. Okay, so in the last video, we started to look through it and we spotted that if we were just looking to solve it, we perhaps didn't need to do it. And that is correct as long as it works, and that's what we're asked to do. Okay, but a lot of the time, it's never as simple as that. Okay, there's always something more to it, and so if we can get it into our upper triangular form, it helps us to spot these things, these problems, whatever. So, first thing I'm going to do then is I'm going to, well, as always, I'm going to get to keep my first line the way it is. Next thing I'm doing is I'm looking to get these zeros, everything underneath that first one in that first column needs to become a 0. So my row 2 is going to become row 2 minus 2 lots of row 1. And so I've got 2 minus 2 lots of 1, so that's 0. And then I've got minus 5, minus 3, and minus 14. Set my dotted line down so I don't lose my place. Same idea, this time row 3 is going to become row 3 minus 3 lots of row 1. And so that is going to give me 0, minus 5, minus 3, and then minus 15. Okay, now we hopefully are starting to spot some distinct similarities here between my bottom two equations. What that is going to mean is when I come on to do the next bit, again, still going to have my top one, 1, 2, 2, 11. My second line is 0, minus 5, minus 3, minus 14. Okay, start to make my matrix up. But when I'm coming to do this, my row 3 is going to become row 2 minus row 3. And that, when I actually start to work it out, is going to give me 0, 0, 0, minus 1. In fact, no, it will just give me 1. Never mind. So, what we are seeing here is that my row 3 is suggesting that 0 is in fact equal to 1. Because what we're saying is we've got no lots of x plus no lots of y plus no lots of z give me 1. Okay, and so this is what tells us that the system of equations is in fact inconsistent and that there are no real solutions. Okay, and that is the first of the kinds that we are going to look at. So again, what we found is this kind of inconsistency in what our answer is suggesting. Okay, we've got nothing on this side producing something on the other side, and that can't work. Okay, so we can't have, it doesn't matter what numbers we put in for x, y, and z, as soon as we multiply it by 0, we're going to end up with 0. Okay, and that is what makes this wrong. That's what makes it broken, and that's what tells us, right back to these things at the top, that there are no values of x, y, and z that will meet all three of these conditions.